10.3 area. Now I'll be doing the area topic in 3 videos. I'm going to be covering basic shapes. So we're talking circles, triangles, rectangles, things like that. Then I'll be moving on to Heron's formula in the second video with a couple of examples. And in the third video, I'll be covering composite shapes. So just a refresher, a composite shape is 2 shapes that are stuck together. So our learning intention, how can we calculate the area of simple and composite shapes? Our success criteria, I can convert between different measurement units. I can calculate the area of a variety of shapes, and I can use Heron's formula to find the area of a triangle. So as I said, this video will cover units of measure. It'll also cover basic shapes. Second video, Heron's. Third video, composite shapes. So converting between area units. When calculating area, use the following flow chart to convert between units. So first of all, the difference between perimeter and area is that we're now talking the inside of the shape instead of just the border around the outside. Because we're talking about area, we also need to square our units of measure. So just like we're going from one unit of squared measure to another unit of squared measure. Previously, in perimeter, to go from millimetres to centimetres, we would divide by 10. Now in area, when we're talking about millimetres squared to centimetres squared, we now divide by 10 squared. So what you need to remember when you're converting units in area is because you've got that little squared sign on your current unit of measure, whatever you used in the perimeter, you just square it. So instead of divided by 10 from millimetres to centimetres, from millimetres squared I would convert to centimetres squared by dividing it by 10 squared, which is 100. A couple of examples on the next page. So, page 181 of your textbook if you're following along. To get from metres to centimetres, so I've got 55 metres squared. So I'm talking area. And I need to get to centimetres squared. So according to my chart down the bottom, I would multiply that by 100 squared to get to centimetres squared. I'll put my centimetres squared there. No, let's just put a squared there. That'll do. So I've got 55 times 100 times 100, which gives me 55, and I've got 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros, and I end up with centimetres squared. Pretty easy and straightforward there. Now my next one, I've got 2,350 millimetres squared. And what I need to do to get to centimetres squared, go from millimetres to centimetres, I would divide that by 10 squared. So 2350 divided by 100, because I know that 10 squared is 100. So 1, 2, moving my, where's my little thingy? If I'm dividing by 100, I would move my decimal from there to there, and it would end up in there. So I've now got 23.5 centimetres squared. You can use a calculator, it's going to do the same thing. Now, 0.8 kilometres squared to hectares. We can do this one of 2 ways. Down the bottom here, I've got my hectares. One hectare is equal to 10,000 metres squared. We can either convert to kilometres, convert from kilometres to metres, then from metres to hectares, or we can use this bottom one here and say 100 hectares equals 1 kilometre. Now, it's a ratio thing. 100 hectares is to 1 kilometre. I've got 0.8 of a kilometre, so I'm talking how many? To get from 1 kilometre to 0.8, let me just have a look. So 1 divided by 0.8, I divided by 1.25. Let's see if this works. Now to get from hectares to how many I've got here in 0.8, let's try this, divided by 1.25. So we go 100 divided by 1.25, gives me 80 hectares. Surprisingly, it's the right answer. So using ratios rather than actually converting units of area, I found that 1 kilometre was 100 hectares and 0.8 of a kilometre is equal to 80 hectares. As I said, I could have actually converted this to 800,000 metres squared, then divided by 10,000 hectares to get the same thing, but ratios were a little bit cleaner. Now, onto area. A lot of these you will have seen over the last few years. The area of a circle, pi r squared. Remembering from circumference that if you don't have the radius, but you have a diameter, the radius is half the diameter, and the diameter is 2 times the radius. Half the diameter, done. Remembering the diameter is that whole thing from one side to the other. That's your diameter and that's your radius there. So in this instance, my area is equal to pi times 23 squared. Remembering to use the pi button on your calculator and not just rounding it to 3.14. So that's equal to pi times, I'll just pull my calculator out, 529. A bit slack. I actually did this by hand the other day in my head and got the right answer. It's too late at night to worry about that. So if I multiply 529 by 3, I'm ending up with about 1600. And I've got 1661.90. And if we were to round that in to a whole number, it'd be 1662 centimetres and squaring it. Our second example is, it's another shape. It is a parallelogram indicated by these little feather-like arrows on the top and bottom, citing that they are parallel. And then, let me change colours, and then these two here, indicating that they are also parallel. Now the formula for a parallelogram, I muck this up every single time. A parallelogram is area equals the base times the height. In this case, I have a base of 2.1. So this measurement here is actually the same size as what this guy is here. And then I'm going to times it by 150 centimetres. Now, I'm working in metres on the first example and centimetres on the second of the two measurements. So I need to convert this guy here. So 150 centimetres, and because I'm still talking about a measurement and not the area, I use the standard units in converting. So to get from centimetres to metres, I divide it by 100 because I have 100 centimetres in a metre, and I get 1.5 metres. So back down to the bottom here, 2.1 by 1.5 gives me 3.15 metres. Now, it didn't actually stipulate whether I wanted it centimetres or metres. I could have converted the 2.1 into centimetres. So 2.1 metres into centimetres means I have to times it by 100. I get 210 centimetres. 31500 centimetres squared. Oops, I forgot the squared on my metres. So if I wanted it in centimetres, it would be 31,500 centimetres squared. If I wanted it in metres, it was 3.15 metres squared. Again, the example didn't stipulate, or I'll rephrase it, I didn't read it, as to what unit of measure it asked for. Now the last one is a right-angled triangle. In the next video, I'm going to go through Heron's formula, which you would use if you don't have a right-angled triangle. Best example, it's a scalene triangle. If you've got a right-angled triangle, it's just as easy to use the half base times height. So area equals half base times height. I firstly need to find my third side, which I'm going to call B. I'm going to change colour because it's going to take up a bit of space. So I've got to find this guy here. I've got my C value and I've got my A value. And remembering our formula from last lessons, for the for Pythagoras' theorem, B squared equals C squared oops, wrong one, let's go minus A squared. 25 squared is 625. 15 squared is 225 equals 400. So my B squared value is 400, therefore B is equal to 20. Just something I seem to know. It also indicates it's a 3, 4, 5 triangle. So it's a Pythagorean triple. No, it doesn't say 3, 4, 5, but they are multiples of 3, 4, and 5. So 3 times 5 gives you 15, 4 times 5 gives you 20, and 5 times 5 gives you 25. Therefore, you've got your triangle being a 3, 4, 5 triangle. So I'm going to go back to blue, and we're going to find our area using our B value. So my B value of 20 is my height, and my 15 is my base. We don't use the hypotenuse in the area formula when working out a right angle triangle. We stick to the two sides that connect to the right angle. So the area is equal to the half times base. Oh, why am I writing that out again? Half times 20 times 15, which is equal to a half times 20 times 15 is 300. Half of 300 is 150. Because we're talking about area, we're talking centimetres and squared. So back to our examples. The first example of a triangle, our formula is area equals pi r squared. The second example, it looks like it's a rectangle that's been pushed over, and that's our parallelogram. The area is equal to the base times height, and a right angled triangle. Because we didn't know one of the sides connected to the right angle, we had to find that using Pythagoras, and don't use a hypotenuse. Then we use the standard area is equal to half base height to find our area of 150 centimetres. I will be back with part 2.